Okay. Here you should know the difference between immediate addressing and this literal, because you may feel that immediate addressing is also somewhat like that only, right? Similar, because in immediate addressing you have just a constant in the place of operand, and that operand is prefixed with the hash symbol. So then you will convert or assemble that instruction by using immediate addressing. But there is a slight difference is there between immediate addressing and literal. In immediate addressing, what happens? Operand value is assembled. Operand value is assembled is nothing but operand value will be translated or converted as a part of machine instruction. Okay, so the operand value is converted or assembled as a part of machine instruction. But in a literal, what happens? In literal, the assembler generates specified value as a constant value. So who is generating the constant value? Assembler. Assembler will generate the specified value as a constant. Whatever the value you are writing in the literal as EOF, X05, something. So these all constants. So assembler will generate them as a constant in some other memory location. Okay, so this is the main difference between immediate addressing and literal. So in immediate addressing, the value will be converted as a part of machine instruction. Okay, but in the literal, the operand value, whatever it is, a constant is there, it will be generated as a constant by the assembler, and it will be loaded into some other memory location. So this is the main difference between immediate addressing and literal. And if you observe your program, which is given in figure 2.5, 2.9, you can observe here in this program in line number 45. In line number 45, LDACEOF is there. Okay, so if you observe this operand field, this is a constant operand. Which constant? Character constant, and this constant is prefixed with assignment operator. So this is called as a literal. Similarly, here one immediate addressing is there, here one immediate addressing is there. So this is the difference between immediate addressing and constant, which is prefixed with equal mark, then it is called as literal. And what exactly happens in immediate addressing and what exactly happens in with the literals, already just now I told you. Okay, so then if you come to line number 215 also, in line number 215 also you will find out one more literal, that is equal x05. The same literal is once again repeated in the line number 230, that is x05. Okay, so like this, in the entire program from top to bottom you have three literals here. One is CEOF, second one is x05, one more is again x05. So total these all three literals, if you make a group of these three literals, if you make a set of these three literals, and you should write that literal pool at the end of the or bottom of the program here in this portion. Okay, so in the next program I will show you how to write that literal pool. Okay, don't worry. So but one condition is, in this program totally you have three literals. In that one, first one is CEOF, second one is X05, third one is also X05. Okay, so here what happens here, that X05 is repeated two times here. Okay, X05 is repeated two times. So here what happens, so instead of taking two copies of X05 in a literal pool, we can store it as only one copy. Okay, so instead of making a redundancy or a repetition, so we can make a entry in that literal pool as only one. Okay, no any repetition in a literal pool. So EOF will be there and 05 will be there in a literal pool. Okay, clear? In line number 45 in figure 2.10, you can find out here all the literals I have circled here. So this is one literal. Okay, and this is one literal here. Okay, okay, then this is one literal. This one is one literal, this one is literal. Okay, you can observe here at the end of the program with the star, I have written here as a literal pool. So this literal pool contains, there is only one literal is there. Okay, in this literal pool, sir, you have find out more than one or two literal literals here, but you are telling that here there is only one literal is there. Of course, why it is like this? Just wait, I tell you. As I told you, literal pool will be written always at the end of the program. And here I should write actually one or two another other two literals here, but I have written only one literal here, which is a very recent literal. Then what about this previous long back? Already you have seen this literal, no? CEOF. So I told you earlier only there are some situations are there where you no need to write the entire literal pool at the end of the program itself. There are some situations are there are some necessaries are there where you should write the literal pool so in any part of your program. Okay, so why sir you have written here? It means that if you observe carefully here CEOF is there. Okay, so CEOF, and you if you find that CEOF here, it will be long away for this instruction LDA. Okay, so it will be a long away for this instruction LDA. So after that, what is there here? Buffer is there. Okay, so after that buffer is there, and if you observe, the length of this buffer is 4996. That is nothing but it is 1,000. That 1,000 bytes will be crossed, then you will get the CEOF literal. So instead of that one, what I am doing, instead of that, what I am doing in the symbol definition section of this portion. Symbol definition of this portion means this is the first top portion is logic, and this portion is a symbol definition portion of your program, correct? In the beginning of this symbol definition program only, I have written one literal pool here. So that literal pool, how I can write it? By using one assembler directive LTORG. Okay, so whenever you want to write the literal pool in the middle of your program, in any part of your program, at that time you should use this assembler directive LTORG. So this LTORG contains one literal, that literal is EOF literal. Is it clear now? So these two literals are completed now. In your program, two literals you have written. One is EOF and another one is X05. So in the bottom of your program, you have written one literal pool, and here no need to write that assembler directive, because by default we are writing the literal pool at the end of the program. Okay, but sometimes if you want to write the literal pool in some other portion of your program, in the beginning or in somewhere else in the middle, in any point of your program, at that time you should explicitly use this assembler directive to tell to assembler that I have written some literal pool here. Okay, so you should get at least one or two literals in this literal pool, and at the end of the program again there may be one literal pool. There again you may get some literals. Okay, like that this programmer is telling to assembler. So this literal pool is written here by writing the assembler directive LTORG, and immediately in next line you should write that literal here. Okay, so like this in a literal pool you can write any number of literals, and you can make it as a group of your literal or set of literals. Is it clear? So this is about LTORG assembler directive. Okay, here you can see here all the literal operands in the program gathered together into the one or more literal pools. Normally, see here. Normally, usually literals are placed into a literal pool which is written at the end of the program. Okay. Normally, usually what we do, we write the literal pools at the end of the program or at the bottom of the program, and in that literal pool we will write the list of all the literals whatever we have used in our entire program from top to bottom. Okay, but the assembly listing of a program containing literals usually includes the listing of literal pool, which shows the assigned addresses and the generated data values. Such a literal pool listing is shown in figure 2.10 immediately following the end statement. Already I have shown it. Okay, that is at the end of the program you have written one literal pool for x05 with the star there, right? But in some cases it is required to place the literals into a pool at some other location in the object program. See, this is why we have to use LTORG assembler directive. So we can achieve this by using the assembler directive LTORG as shown in this figure 2.9 in line number 93. When the assembler will look into this LTORG statement, then it will understand, oh, it is a literal pool. And here programmer has listed some literals. Okay. So it is a literal pool that contains all of the literal operands used since previous LTORG or beginning of the program. It means when assembler will look into this LTORG statement, it will understand that, oh, this is a literal pool where the programmer wants to list some literals, and what all the literals he will list the, so the list what all the literals the literals what all he has already used from beginning of the program to till this present line, or else the literals which were present from last LTORG statement to this present LTORG statement, like that. Okay, so assembler will understand this one. Then this literal pool is placed in the object program at the location where the LTORG directive, assembler directive was encountered, where it was present in the object program. Also, this literal pool will be reflected. Of course, the literals placed in a pool by LTORG will not be repeated in the pool at the end of the program. See, the literals, if you have already written in the LTORG, then the same literals you cannot write it once again at the end of the program again. So because of that only I told you there is no repetition, there should not be a repetition of literals. Okay. So here, if we had not used this LTORG statement in line number 93, then what happens? The literal CEOF would be placed in the pool which is in the end of the program. Are you understanding now? So, sir, what happens if I have not used the LTORG statements at all? So then what happens? Obviously, definitely, in your program, there is only one literal pool which is written in the end of the program, and all literals will be listed in that literal pool only. Okay. So then this literal pool will be in the address 1073, because if you observe your program at last address is a 1073. This means that literal operand would be placed too far away from the instruction which is using it. Okay, so to allow this program relative addressing, it means that this CEOF instruction is, sorry, operand or literal is used by whatever the instruction, it has to find out two away for this EOF. Okay, this means that literal operand would be placed too far away from the instruction referencing it to allow the program counter relative addressing. Then what happens? I have to use a program counter relative addressing mode at that time. Okay, so the problem is a large amount of storage reserved for buffer in between. So by placing that literal pool before this buffer, we can avoid to use the extended format instruction, that is format number 4. We can avoid it. Okay, when we refer to this literals, the need for that assembler directive such that LTORG, the need for this LTORG usually rises when it is desirable or required to keep the literal operand. Literal operand is nothing but here, that is CEOF, closer or nearest to the instruction that uses it. Okay, so this is the reason why we have written this LTORG. So it means that by writing these literals in this literal pool, by using this assembler directive LTORG, I can write the literal pool wherever I want, and wherever I want means that literal pool should be near to the instruction which is using these literals. Okay, so by doing like so, we can avoid the usage of instruction format number 4, that is extended instruction format. Okay, so these are the advantages of LTORG. This is very important paragraph. You please have a concentration and read once at your home today. Okay, so most of the assemblers will recognize, most of the assemblers will identify the duplicate literals. So as I just now told you, suppose if you have written already one literal in LTORG, then no need to write it once again in the end of the program. Okay, or else in the same literal pool there should not be repeated literals. So if there is a repeated literals, then it is called as a duplicate literal, and these duplicate literals will be easily identified by these assemblers. And these assemblers are very, very intelligent. You just remember here one example I want to tell you. Suppose if you have a constant or a literal like CEOF, okay, so this is a constant, character constant it is, okay, so it is a character literal. So the same character constant, if you convert it into hexadecimal constant, then it becomes like this, that is 454F46, and which is prefixed with a x, and that x is prefixed with a assignment operator, so that it is a literal. So both of these two literals are same, because here it is a constant, character constant, but here it is a hexadecimal constant. But both of them are referring, or both of them are indicating same constant, that is EOF, because E equivalent ASCII character is 45, O equivalent X ASCII character is 4F, and F equivalent ASCII character is 46. So once you have converted this character constant into hexadecimal constant, this also will be easily identified or recognized by the assemblers. So it will identify it as a duplicate. Okay. So always remember, the assembler might avoid storing both the literals if it recognizes this equivalence. If it gets to know that these both are same literals, both are indicating same literals, then it avoids storing both of them. It will store any one of them. Okay, any one of them. Okay, so here, like this, assemblers are very, very intelligent to recognize the duplicates and avoid the storage of duplicate literals. Clear? So now next is here base star is 0. This statement, what it is indicating? It is indicating that in the register B, because I already told you base is one assembler directive, and the content of register B is always in the control of programmer, not in the control of assembler. Okay, so program counter relative addressing mode will use the displacement formula like this. Displacement is equal to target address minus the content of the register PC. The content of the register PC is nothing but the address of next instruction to be executed, which will be easily identified by an assembler. So it is not in the control of programmer, it is in the control of the assembler itself. But in the case of base relative addressing mode, the content of the register base register B will be in the control of a programmer. So in the register B, what should be present? What content should be present? What should be stored? It is clearly told by the programmer. So here also programmer is telling to clearly the assembler that in the register B, there should be the star. What this star? Star is nothing but it is the starting address of the program or beginning address of the program. So here in the address, LDB instruction is there, right? LDB instruction, what it does, it loads the starting address of the program into the register B. And since this starting address is in terms of a constant, it is prefixed with equal mark here, then this is also one literal here. Okay, so this literal appeared on line number 13 of our program. It would specify an operand with the value 0003, because some starting address of that program may be 0003. So if the same literal operand is on line number 55, it would specify an operand with the value 0020. So if this equal slash equal star, if it is present in 0003, it will store that value, or if it is present in the address 0020, then it will store this address. Okay, so now one more thing, important thing is the data structure. Which data structure? Already you know two data structure, OP tab and SIM tab. In addition to those OP tab and SIM tab, here one more data structure we are using for literals, that is a literal table, lit tab, LIT-TAB. So what is the use of this literal table? So let me to explain, very simple, like our OP tab and SIM tab. Here also one table will be created specially for literals here. It means that all literals will be inserted here one by one, and again this literal tab will be designed as a hash table. Okay, already you know hash table. opcode, op tab table, symbol tab table also will were generated as a hash table with some hash function. So this data structure literal table also will be constructed as a hash table where you have some values and key values. Okay, so here what will be the key and what will be the value? Definitely key will be the literal and value will be the value of that literal. Okay, so this table contains literal name and operand value and length and other address and the address assigned to the operand when it is placed in the literal pool. So these all are content of this table. Remember, the content of this table is what all the literals you have used. Okay, for each literal used, this table contains that literal name, then operand value. Okay, the literal name and value of that literal, that is operand value, that is constant. Okay, then length of that literal. Length of that literal means, for example, EOF, it is 3 bytes. Okay, 05 x05, it is 1 byte length. So length of that literal and the address assigned to that operand when it is placed in the literal pool. These all information will be present in this literal table. So literal table is usually organized as a hash table, and here also key value pairs are there using a literal name or value as the key. Okay, so for each and every literal table, there is again pass 1 and pass 2 will be there. In pass 1, assembler will keep on inserting these all literals, and in pass 2 it will search the literal table whenever it starts assembling. That is nothing but conversion of assembly program into low level program. It searches this literal table for the literals and it will find out the value of that literal. Clear now? So what all the things we have discussed is very, very important today. You please open your textbook today and you read all these things, all these pages, whatever I have scanned and I am showing you here. Every line, every point is important to get the knowledge, and author has beautifully explained all the concepts here. Today, what all the things we have studied? We have studied literals, okay, and literal pools we have studied, and we have studied one assembler directive LTORG, and we have also studied one data structure which is a literal table. Okay, in the next class I will discuss about the remaining assembler directives, equate assembler directive and origin assembler directive. Okay, so just I revise the class short in a short period of time. Just literals are nothing but operands with a constant values. Okay, so those operands are containing those values literally there. So because of that only those operands are called as literals here. And how to denote these literals in our program? If your operand is prefixed with equal mark or assignment mark, then it is literal. Okay, in a program from top to bottom, in an entire program, what all the literals you are using, you have to make a list of those all literals, and you should write it as a literal pool. Okay, that is nothing but a literal pool is nothing but a group of literals or set of literals what you have used in your program from top to bottom. And usually, normally, we write these literal pools at the end of the program or at the bottom of the program, and it is not always true. There are some situations are there to avoid these extended formats, that is format number 4 and any other difficulties. To avoid these all difficulties, sometimes there are some situations are where I have to write these literal pools in the middle of the programs or in near to the instructions which are using those literals. Okay, I have to write literal pool near to or closest to the instructions which are using the literals, these literals. So at that time, no need to search for these literals far away from the line of that instruction or statement of that instruction to the end of the program. So immediately you will find out after some 4 or 5 lines, you will find out that literal in that literal pool. Okay, so here literal pool, sometimes I should write near to the instruction which is using that literal. So to do that one, I should use one assembler directive LTORG. Okay, and immediately then I should write the literal pool. When assembler will look into this LTORG statement, it will understand that, oh, it is assembler directive. So programmer has written one literal pool here to make the list of some literals which were from last LTORG statement, or else the literals which were from the starting of this program. Okay, because any program may contain more than one or two LTORG statements, right? So whenever LTORG statement comes, assembler will understand that, oh, literals are going to be listed here in a literal pool, and these all literals are from the literals from previous LTORG, or else the literals from the beginning of the program. Okay, then we have also studied one data structure that is called as LIT tab. What it means? It is a literal table. So like OP tab, operation code table, and SIM table, SIM tab. This is also one more data structure. This may be also asked in your exam. Keep it in your mind. Very important and interesting. Literal table is also a table, or it is a data structure which is used to store the information, every information about the literals. For example, what all the information it will contain, already I told you. Once again I am repeating. This may contain the name of the literal. Okay, the name of the literal, then uh, value of that literal, and length of that literal. Okay, so these all things will be present in this literal table, and this table is also constructed as a hash table. Okay, so literal name or literal value will be used as here key. Okay, so because hash function means always there will be key value pairs, key value pairs, key value pairs, remember. Then what will be the key of this table? Okay, so literal name itself you can take it as a key, or else its a value, literal value you can take it as a value here, or sorry, key here. Okay, so these all things we have studied. Just go through these all lines, because you can observe here in my presentation only, I have underlined everything, every line by line, everything is I have underlined so easily in so simple sentences. Author has beautifully explained these all concepts. So please, you also read once today. Hardly it will take half an hour or 1 hour with high concentration. Then if you once you understand, once you remember, you never ever forget these all concepts. Very interesting concepts. In the next class, I explain another two assembler directives: equate assembler directive and origin assembler directive. And apart from these two assembler directives, I will explain about expressions also. One more topic is there, very interesting topic, that is expressions. That also I will cover in the next class. Okay, so have a nice day. Now you can do the meeting.